Yeah. So welcome everybody. This is really great. This is actually a little bit of an experiment we're trying tonight. For many of you, you have been participating in our regular Zoom or our regular journal club meetings with the typical format is a paper or two, and then a discussion about those papers. And some brilliant person, I think it was Chris Laser, said, maybe there's a change in format here that we could try for the summer. And I really like the way this is working. So if you were here with us a month ago, we read some papers about a particular technology. And then this is like what we call a little mini workshop. It's the same hour-long presentation, but instead of reviewing papers, we're actually going to dig into it a little bit. Chris is going to walk you through a PowerPoint. We're going to kind of get into some of the nitty-gritty and actually try some things on our own. So I'm not going to get too detailed. Chris will introduce that. But I certainly appreciate everybody coming, and I will just kind of sit in the background. I think I'm going to participate a little bit and show you some of the JPL Horizons things. And but other than that, I'm going to turn it back over to Chris, let him share his screen. And Chris, so you asked us to download a whole bunch of stuff, and I hope everybody did that all right, and we'll see where we go from here. Thank you.
The idea for this actually came out of the general members meeting, where the discussion came up of how can we get field work out to the most people in the membership as possible. Last summer and this year in May, some of the team was out at Escalante Pueblo and Wallace Pueblo to do some field measurements and some digital mapping. But of course, everybody didn't get the opportunity to go to that. And we were trying to think of a way to get more people involved in a hands-on kind of way, even if their hands can't physically get dirty, maybe we get them digitally dirty. So last week we looked at a brief couple of pages, part of a chapter from Mogley's archaeoastronomy undergrad textbook on using virtual globe software, and Bill Romain's paper on pretty much a test of the accuracy of using these tools. And not to put words in Bill's mouth, but the results seem to be pretty accurate depending on your care and the resolution available. So what we hope to do is, let me get in here, is take part of what's going on the ground, which is the Society's Cultural Landscape Surveys program, which has been underway for a couple of years, and kind of add to that with the greater membership. With this workshop, we're going to do some looking at some of the work that's been done already and some work that hasn't been done yet, and some future possibilities of how a format like this can add a little on the edges, to make the whole cultural landscape survey program a little more robust in certain sites that are, private property or would require permits, and give us a more holistic view that we can get actually ground truthing things. So just kind of a couple slides, modified, lifted from last month. Everybody has this available to look at. Of course, what we're going to be talking about is horizon coordinate systems and finding our values in the horizon coordinate system, and then using them to try to find astronomical declination of a point on the horizon, which is our equatorial coordinate system. So the horizon is what we measure, and what we eventually want is one of our two coordinates from the equatorial system. And the reason for that, let's just back up a little bit. What we want in the horizon system is we need an azimuth. So the azimuth, of course, is the angle from true north, that we're looking at. So the couple different ways we can get that is we can measure our bearings for magnetic north and apply our corrections for magnetic declination. Or we can measure directly using sun sighting and get our our azimuth that way, or we can use some of the tools that we have available here in Google Earth that we're going to discuss tonight. The other factor we need is the horizon altitude that we could get in the field with a clinometer or a theodolite, but we're going to try to get that value here with some of the embedded tools and some other ones that we're going to look at, as well as the latitude. So once we have these three things, the latitude, the horizon altitude, and the azimuth, we have everything we need to find our declination using spherical geometry equations. Then once we have that value, we can look up the declination on an ephemeris and find out the days of the year that the sun rose at that point on the horizon, which is going to be the end game for a couple of the exercises that we will get done tonight. So this picture here is taken by the guys on the ground last month. It's Escalante Pueblo, and if you can see, it's a little bit faint in this picture. In my picture, the actual peak of Hesperus Mountain there on the horizon. And this first exercise, what we want to do is we want to find out what day of the year does the sun rise over this peak. So this is more of an exercise in finding out, what day does this, what day does the sun rise there? We're not making a point of, well, let me just put it this way. We haven't gone through these calculations ourselves. So this is the first time we're doing it all together. So I hope everybody has Google Earth downloaded and ready to go. So I put a little bit of some context wrapped around this this first exercise. This was taken from Greg's article in the last newsletter, where he discussed some of the cultural landscape survey program accomplishments from last year. So if everybody has this, they can look at it on their own. And then what we've talked about here with this exercise is Hesperus Mountain, this peak that we have here. Here's a little bit of context here. So these two slides that I just showed you are for you to come back to at your leisure as we work through the exercise and maybe try to wrap some meaning around here. Because this is what we're going to do for this exercise. Here's an aerial view that Chris mapped out with drone this year. So we want to find what is the latitude for the observer at the observation point. Where are we going to observe from? What is our latitude, and what tools are we going to use to find our latitude? Tonight, that's going to be Google Earth Pro, and that's where we're going to pull our latitude from. So what is the azimuth from the chosen observation point to the Hesperus peak? So as we learned last month, the tools we're going to use for that is the ruler tool. And then what is the horizon altitude? And for here, it's same as last month. We learned we're going to use the elevation profile tool. Then we can use our calculations using geometry. And additionally, we can use the profile at heywhatsthat.com. We discussed using the Horizons program, but that might have been a little bit more than we wanted to bite off in one evening. It's a better tool. It takes a little practice to use, so we're gonna use a free one here that's a little coarser, but it should serve our purposes. And then we're going to find out what's the astronomical declination corresponding to that peak. There again, we'll use our spherical geometry scientific calculator if we wish. I have an Excel spreadsheet that we can use as well. If you guys want to come up with your own values, I can plug them into the spreadsheet, for everybody, and we can come up with everybody's declination in one spot. From this position, what 2 days of the year does the sun rise over that peak? The tools, again, we're going to use for that are ephemeris that we're going to generate from JPL horizons. And then the last question is, what cultural significance might one or both of or none of these days hold to the builders of the Escalante Pueblo? So we have a couple of slides previously that talk a little bit about context, and this is more of a question to actually think about more than just angles and numbers, but cultural meaning. So with that, you know, let's jump in. I don't want to walk everybody through everything. You know, I certainly want to give people time to work through it on their own and not just watch me work through it. So I'm not quite sure how this is going to work, but does everybody have Google Earth open and found Escalante Pueblo? So
it's kind of going to be kind of hard to converse with people, but yeah, I think if anybody sort of, if you're savvy with Zoom and just want to drop little comments into the chat, actually, it would be really nice. So see how that works.
At this point, Rick, I don't care if everybody wants to go off mute and do it as a conversation, because I don't want to lecture this out. I want us to work through it together.
I get it. No, I think that's a good idea. There's not too many of us. So if you have a comment, and I wouldn't mind hearing just how many people actually have taken the time to, do you have Google Earth open, and have you found this particular location? Gordon, I think you have, right?
Yes, I have it.
Okay. Okay. So yeah, hopefully everybody has Google Earth open. See, we got somebody here in the chat. Go ahead.
Thank you.
Okay, great. Let me just move the chat up here so I can keep an eye on it if anybody is interested. Like I said, I hope everybody is not only following along, but actually going through the exercise at home. So I hope you have.
Yep. Rich is just going to watch. Rich is just going to watch us do it. Hey, Chris, do you mind if I just explain what you're seeing here real quick? Because I don't think you were out
absolutely.
there. But,
like I said, I don't want to lecture. Like the
big white.
Have an open discussion.
The big white rooftop, but just a little bit below the Escalante Pueblo marker there, is the visitor center, and it's the headquarters for the Canyon of the Ancients National Monument. So this is their big sort of, you can see a parking lot there. And then what doesn't really show up very well here, but there's quite a little climb from the visitor center up to Escalante Pueblo. And you can see actually some little walkways tracing through just to sort of up to the left just a little bit. You can see some switchbacks there, and that's the normal public way to get up there. It's really about, it's only 100 yards away, but it takes you half a mile to sort of like make your way up through these switchbacks and up to the top. And so the Pueblo itself is on a really nice little promontory just sticking up, and it's really a beautiful place to visit if you haven't yet. Go ahead, Chris.
So I'm gonna zoom in so we get to what we can see. And if you can see here, this is the default image that Google Earth Pro gave me tonight. It's not terribly useful, right? But if you look up here, we have this historical imagery icon. It's a clock with a kind of an arrow going counterclockwise or back in time. And we can actually select different images with different resolutions from historical images on Google. I found this one to be a pretty good one to work with. It's, my bars covered it up, but I think that's her. Okay, that's 2016. So can everybody just, give me a visual, or, on auto, you can use your icons on the bottom if you wish, if you don't want to speak up. I think we have them here. Do we have a thumbs up icon? Maybe not.
It looks really good from my perspective. It looks really familiar. We were just up here about 3 weeks ago. So.
Okay, well, anyway, if you have any questions or any input, just feel free to jump in. Like I said, this isn't a lecture. This is all of us working together on a workshop. So if you recall, what we want to do here is we're looking for, let me pull up this slide again, and everybody should have a copy of the slide deck, of this slide deck available. It was included in the invite. So I hope you had a chance to print it out. That's what I did. But here, this peak right here, how are we going to get the day that the sun rises right there? And what I'm going to use actually is this, the same site here that the theodolite of the transit set up for, which is this wall down here. So if you look, we have a pretty good line here to this wall. And if you recall from last week, the way we're going to get our azimuth, or more appropriately our heading, is to use the ruler tool. So to do that, what we're going to do is click at one spot, and then we take it out, and we're going to create a line. So I'm just going to create, this line here is an example. This is obviously not going to do it for us.
Hey, Chris.
Yeah.
Yeah, just a comment. That image looks a little bit tilted. So you always want to go to view, to up there at the top of the screen, and make sure that your tilt is set to horizontal. You know what I'm saying?
Yep. Yeah, and
well,
that's a good.
I don't use that so much as you'll see at the top of the screen where it says view, and then there's a drop down menu, and you see where it says well, let's see, go to tools rather. Go to tools. Go back to view. I forgot what the heck I was doing. Anyway, there's a drop down menu that gives you the option to correct the tilt and there it is, tilt and compass. Tilt and compass both.
Oh, perfect. Thank you, Bill. I didn't know about that one.
Which one was that?
Go back to that.
That's great.
Go back to that tool again.
Yep. That's a great one. I wish I would have known that when I put this together.
Now,
so we're going.
Wait a minute. You see where it says tilt and compass? That's the one that you want to click on.
Oh, okay.
So that you get them both. So you get both options done. There you go.
Okay, great.
You got it.
So did everybody catch that? We went to view, to reset, and then tilt and compass, and then we get a much better, a much better look down from like a nadir position. So I'm going to clear out my line, and we can create a much better line then. Again, this is just a short line that I'm doing here, but close it out and start over. But what we want to do is we want to take our line all the way to the peak of Vespers. So let me just get this much for now. So is everybody with us so far? Does everybody at least have Yep. So does everybody at least have like a small line drawn and some heading? And please feel free to speak up.
Yes.
Okay, great. So right here, I did put in the peak of Hesperus. These coordinates came off of Google Earth. So what I did is I created a marker at Hesperus Peak, and I'm just going to make my screen a little bit bigger. Let me get out of here, and I'm going to start my ruler tool. Well, let me get back in here. Sorry about that. I'm going to start my ruler tool. Just get my first point, which I'm going to put right about there. And then I'm going to zoom out because I've marked Hesperus with a pin. And you know what? Let me just do that again. All right, let me delete this guy, and I'm gonna show you how. I'm gonna create. Well, I'm gonna go to the coordinates. So they should be on the slide. If everybody wants to, I can just read them out loud. There you have your Google Earth up. 37. I believe I could just do spaces, right? 26. Maybe not. You know what? I'm gonna do this. This might be the best way. I'm gonna take the coordinates here, copy them, and I'll put them in the chat. So everybody can just copy and paste them. So these coordinates took us to the peak of Hesperus. I'm going to put my pin there. Is everybody still with me? And then I am going to go back to Escalante. So we can see it's pretty far. So here I am back at the Pueblo. I want to make, I'm going to start my line here because this looks like our cleanest spot. And just hover over my zoom out button, slide this over a little bit. To my Hesperus peak. here. There we go. And that's my line. So just out of curiosity, I'd like to hear what everybody else got. I mean, if you printed out the worksheet, there's a spot there you can write your values in. So if I move this out of my way, my latitude for Escalante, well, I'll come back to that. I've got my reading here. Can everybody just tell me what they got for their readings, if they did theirs already?
Chris, I can tell you that the image you use with the transit, that's me and my transit, and I got 95. So that's about as close as, yeah, that's about as close. I think I can get within, probably a quarter of a degree with the settings I have. So 95 and 94.95 is pretty darn close to the same thing.
Yeah, I like that.
I see there's one of the users got 94.75.
Perfect. Yep. Good.
A fraction of a degree.
Yeah. Which is very good.
Rick,
Okay, so yep.
Rick, did you say you got that measurement using transit?
Yeah, I did.
What transit are you using, and how
Oh,
confident are you about the magnetic declination in that area? Because I know that
well,
you got some anomalies
yeah,
there.
my transit doesn't, I don't use the compass function. So what I do is I actually, prior to going out to doing a site visit, I scope out just like Chris is doing, except on GIS. I scope
Okay.
out essentially the locations of a number of peaks. So on both sides of the horizon. So in this case, it's what do they call that one? Sleeping Ute Mountain on the southwest, and this one in the east. And then I set up the settings for one of those peaks, and then I measure the rest of them around that. So
okay, so you're using ArcGIS. You're not just taking magnetic declination readings.
that's correct. Yeah, no, I'm actually doing. I'm finding peak
Gotcha.
azimuths online, and then sort of ground truthing them on the
Gotcha.
so
Okay, thanks.
I'll give you the model number of that transit though in a minute.
Well, I just was curious. It looks like a wild, maybe.
Yeah, generally what we do for determining the magnetic declination locally on a particular day is use the NOAA magnetic declination site.
Yep.
Yeah. Do you have like some unusual anomalies down in that area? Magnetic anomalies that you know
No,
of? Are you aware of?
generally not that I'm aware of around Mesa Verde. It's not, the sandstone does have some iron in it, but it's not really.
Yeah.
We've run over this over and over up when we did survey up at Mesa Verde, and it's just not significant sources.
All right. Sorry to interrupt. All
No
right.
worries.
Thanks.
No, it's an important issue.
Right. And it's a conversation, not an interruption.
Yeah. Exactly.
Okay, so everybody's got a line here that's roughly 95 degrees. And then when you're happy with your line, we're just going to click save. And we'll call this, just give it anything you want to call it. I don't know if I spell anything right, but good enough. So once you save it, your line. I'm sorry, what did you say, Rick?
Well, I was just going to say this is what that thing looks like. So let me see if I can stop blurring. It's a David White This model is called a realist.
Oh, okay. Once you save your line, it's going to go from yellow to red. And once it does, you can get into, go to edit, and you can do your show elevation profile. So I did not anticipate that. So it's not really showing us anything here. So the plan was to take our elevation profile. This is a different site. And what we could do is we could take our height as our opposite line and our distance as our adjacent. And if we wanted to solve for here what I have theta, which would be our altitude, we can use the equation tangent of theta equals opposite over adjacent. But it doesn't look like this particular line is giving us any data. So we go to the next page, we can use hey, what's that? So I invite everybody to go to the website, hey, what's that? And once you type in www.heywhatsthat.com, can everybody see my screen? I actually already have it here. I'm going to again drop the latitude and longitude that I used for Escalante and Pueblo into the chat. Just so you don't have to do, well, you wouldn't have to do any conversions. Sorry about that. It looks like I didn't actually send the other coordinates. But there you have Hesperus coordinates followed by Escalante Pueblo.
Now, did you actually draw that from the theodolite picture down that wall, right?
Are you asking about this profile right here?
No. I'm talking about the line that you drew.
Oh, yes. So
okay.
So what I did, let me just back it up. I took the coordinates for the Hesperus Peak.
Right.
That's in the handout, and I placed it into my search bar.
Right.
Which took me right to the peak, and then I moved my pin to the highest point by zooming in on it. I zoomed in on my observation point at Escalante Pueblo, zoomed in and got really right where I wanted to look from, and then I zoomed out and I moved over to my pin. I zoomed back in.
Okay.
And drew my line. Once I had my line drawn with yellow, I saved it and I named it, and I was hoping to get a better elevation profile, but I did not.
Chris?
Yep.
When you're using these different horizon elevation or horizon altitude tools, some of them correct for refraction and some of them don't. So
Right.
you want to check which one. And I don't recall off the top of my head if hey, what's that corrects for refraction. I think it does. But anyway, that's something you want to check if you use horizon versus this one, or let's say there's another one called Peak Finder, which also works. So yeah, you just want to make sure that you're you know what is given you in the way of numbers.
Right. And we're gonna talk about that a little bit later too. Rick's gonna talk about that with generating the ephemeris as well.
Okay.
The effects of refraction. So going back to, hey, what's that? Since we don't have anything here to work with, I'm going to pull this up, and here we have a little checkbox. It's here it says show 0 degrees and 1 degrees. It gives us exaggerated lines. But what we can do is we can take our mouse. Now, if you see that we could slide it here, our azimuth and our altitude changes with our cursor. So if we go over here to roughly 95 degrees, and then up, obviously this is not, terribly precise as some of, the other applications that we were talking about, like horizons or things like that. But we can see here, this giving us a very coarse reading of about 2.17 degrees. And does everybody come up with that on their own, or I'd like to hear what everybody else?
No.
So my transit measurement when we were out there was 2.57.
Okay. So that's going to be probably a lot more accurate than hey, what's that? I would think.
Yeah, I don't know.
But 2.57. So we're off about what, 40, huh? Little less than half a degree. And there we have, if you're filling in your form here, actually, we have the latitude right there as well, 37.4. 7. So we have an altitude here at 2.17 measured on here, or whatever you came up with. Obviously, this is very coarse because our image is small, the mouse is small. Rick's measurement of 2.57, is to be taken a lot more accurately. But I'm not going to steer you either way. Which value you want to use. We can use both. But if we move back to, let me just go over this again too to make sure everybody's here on the same page. So I put the coordinates in the chat right here. If you go to hey, what's that? You add the latitude and the longitude.
I think I actually found a problem. Let me sort of introduce. I don't know, sort of like just
the elevation.
The elevation you have here for Escalante and Pueblo is 7711, and the Google Pro does that at 72 something. I used 72. What did I use?
Let me go back here.
So I'm not sure why there's such a difference there. I use 7222. And that would be the difference. I would speculate that's the difference in what we're seeing. The difference we're seeing in that particular angle, or the altitude.
Okay.
Because you're measuring from a higher. I think WhatsApp is measuring from a higher distance. I don't know why there is that much difference. That's 500 feet. I guess it might make that much difference.
So let's see what it does actually. Let me go back. Let's see if it keeps mine. It doesn't. So let me just go to a new panorama. Okay, perfect. It saved that. And what elevation did you put in here, or should we not even put in an elevation maybe?
Well, I don't know where it's getting that elevation of 7,700.
Yeah.
I have
So-
7,200, so
You put it 7,200?
72.2.
So let me generate a new image. See if that gives me a new.
And then you're also right. It's a pretty coarse resolution, just the WhatsApp program.
Yes,
So,
yes,
but-
it is.
but if you know the two values and measure the distance between the two, that's also another way to do it. So you know,
Right.
Escalante Peak
I was
has a
hoping.
value.
Yeah. So that's not right.
Nope.
What happened there? Took away the negative. We're looking at somewhere in Europe.
Yeah, we,
Well, there's my negative. Let's see.
If you want to use
And-
7,222
oh,
and just above sea level, of course, instead of above
7,222.
ground.
above sea level, not above ground level.
Oh yeah, right.
And 7,222.
222.
7,222. Yeah, there you go.
We probably also need to,
That looks better. So there, we go to 95 and head up. There we get 7.45. And you got
So I was-
seven, oh,
I
7
was
point, yeah,
Two-
I think
I got 2.57.
okay,
So that's pretty darn close. I think that
Yeah,
was the
that's good.
difference. Is we just
yeah. Perfect. I'm
So,
gonna use
so, Rick,
yeah.
the numbers that you got, did you actually use the trigonometry method in terms of distance and solving the equation, or did you let the transit give you that that altitude?
I did it both ways. So in advance of me going out, I went ahead and did the trigonometry. Before I did the transit, and then my transit confirmed what I started with. So yeah, I mean it's raw. I mean I can be a tenth of a degree off just because of my dials are small and my eyes are 65 years old. So, but
Yeah.
it was close enough that so I have it at what is this? It's 132 kilometers if I have it
Yeah.
correctly. No,
Really?
I did
So
it
you-
in
yeah.
feet. I'm sorry. No, it's I don't know the division there. But yes,
given
I did
the,
it. I did it.
yeah, well, I think that you got some great correspondences there between what you just did and what the transit said. But that little teeny tiny difference could probably be attributed to the shuttle radar differences in elevation. I mean, it's not precise. It's accurate only within plus or minus 16 meters in that vertical height.
Yeah,
and,
you're
you know,
absolutely right. So I'm sure we're not going to get much better than that just because of the variables. So
Right.
Yeah.
Right.
I'm very happy now between the 2.52 and the 2.57.
Yeah, I think that's
Yeah.
great. That's really good.
probably a little more precise than that.
So here's the equation that we could work through with a scientific calculator if we had more time.
I'm
but
just-
I'm gonna
I'm
show
just
you.
curious to know if anybody has done that. I sort of I love that formula. I love the calculation. So as soon as I saw
Yeah.
Chris do this, I started plugging them in and all that stuff. I don't know if anybody's taken the trouble to do that, but it really is. It's like magic. I
It
think
is,
it's magic.
but we're going to
It's
even
an
do more
amazing
magic.
formula.
We're going to even do more
Okay.
magic here. So what we're going to do is I'm going to ask for everybody's values. Does anybody want to give us their values, what they came up with?
Gordon's been following along. Gordon, you're on.
Yeah, I don't have it. Yeah,
Okay.
I've
Well,
been-
then
I've been-
I'm gonna put in Rick's field measurement and Google Earth. I don't know why it's not letting me type in. So, Rick, you in the field, we're gonna go with 95, right?
Yeah, just go 95. That's within the accuracy of my
And
eyes.
altitude you got was
2.57.
2.57. And then, did you record your latitude?
Oh, I don't have it on this. Let me see. I'm sure I have it here. I'm going to use site latitude of 37.4777.
Well, that's what I used from Google Earth.
Okay, that's
So-
probably where I got it.
Our measurements are 94.95 from tonight, 2.52, and the same latitude, 37.447,
447 or 477.
477, thank you. And we have
Look how
destination-
close we are. Chris, we're pretty close.
pretty close. So I'm going to take that value and I'm going to fill it in right here.
Hey, Chris, can you go back to your spreadsheet for a second?
Sure thing.
Doesn't this normally do this in radians? And can you just show us a formula? Like under, just hover over one of your, we can't
Okay.
see the formula.
Yeah, I will do it this way. How about this? Unhide. Let's see. Unhide.
Which is, I used to use, I did this a lot in Excel several years ago, and I just had to always make the conversion from
Yeah,
radians to
this is in
degrees.
degrees. Yeah, this is
It is, okay.
specifically for this. Fabio Silva built the spreadsheet.
Oh, okay. So
Sure.
yeah, so if you're trying this on your own in Excel, I think the default in Excel is to do all this angle calculations in radians. And for me, there is a way to change the formula so you can kind of convert it to degrees anyway, but it's a hassle, quite a
Hey,
hassle.
Chris, that spreadsheet's pretty cool, but you should also know that Clive Ruggles' website has a calculator where you simply input, much like this, but you input the azimuth and the altitude and it returns the declination. And it makes I think it makes the refraction corrections as well at the same time.
Oh,
So
I completely forgot about that. Thank you
yeah,
very much.
pretty cool. He's got a pretty cool site.
Yeah. I did completely forget about that one. So to move ahead. We're going to jump over to, we have our declination. So we have the question posed is and let me just go back. So we have our, going up or going the wrong way. So we have our astronomical declination of this point right now that we just decided was negative 2.39. So now we want to know what day of the year does the sun rise at that declination. So to do that, we're going to jump over to this website. which is the Horizons JPL app. So this is, looks like it needs a second to come up. This is where we're gonna edit some things here. We're actually just going to look for the sun, right? That's all we're concerned about here. This is our latitude and longitude. You know what? Let me change. So this is -108. And I can just do 32, 43.98, right? Here I can do 37, 28, 39.47. I just redid this because our feet, again, Rick, that was 7222.
Yes.
There we go. That's better. So the time I set, the earliest construction date that one of the first slides where we're talking about some of the context of the site was 1120. So if it was built in 1120 and it was meant to line up to a certain declination, that would be a good year to use. So I put in here from January 1st to December 31st. And then lastly, the settings, I only put in declination. Rick, you want to add refraction or? Or do we want to just keep it?
I'm sorry, I was muted. Why don't you go ahead and go through your process here, and then I'll go back afterwards and just show people how to deal with the refraction question here.
So I'm just going to use it at that then, and I'm going to generate the ephemeris. And right here it is. So here's our declination at the end. To answer our question, there's going to be 2 days of the year that come close. Our declination is -2 point roughly 39. Here we have sunrise February 24th. February 24th. And
intuitively, it seems right? It's coming up from the south, so it's going to be short of.
Yeah. And this, I would say, was our next closest to -2.39 of September 11th. So again, if
That doesn't,
doesn't feel right,
no, it doesn't. For some reason,
Well-
as I'm thinking about the site of, Hesperus is at 95 and east is 90, and the altitude isn't that much. It would seem like with the rate that the sun is moving at that time, it seemed like it'd be a lot closer to what we traditionally know as the equinox.
it's really moving fast at that time. So if it's not right there, there's going to be a big difference between days. Like, let's go back.
Hey, go back. Yeah, go back to your table.
So if we're, if we're closer to, the solstice here, we're hanging out at declinations that are kind of close to it.
Right.
Yeah, yeah.
But as we get
Go back
closer
down to your,
September 11th, we only have 2 days that are in the whole -2 range because it's moving really quick.
Yeah, it is.
So I feel pretty
so
good about
we're,
our declinations.
so go down to September 21st.
September 21st, we're at -6.
Yes,
So our math isn't that off, right? There's no variable that we screwed up bad enough to come up with more of than a 4.
Okay.
Half a degree per day is 10 days is 5 degrees, I guess.
So yeah, it's 4 degrees difference. Okay, yeah.
It's worth taking another look when you do something like this, but it seems like you took all the right steps.
Yeah, I think those are the right days as well. I just, for the sake of time, I'll
Is that
probably,
what you got? Is that what you got before, Chris, when you were preparing?
I made a special point and put in the notes that none of these calculations were worked out ahead of time.
Oh, okay.
Because
There you
we're all discovering it together.
All learning together. All right.
Like I said, I didn't want it to be a lecture. I want it to be a conversation and a discovery. And I'm just gonna let this hang with this last question, which might, warrant further discussion, but what significance might one or both or none of these days hold to the builders of Escalante Pueblo? It's not what we thought, but that kind of makes sense, right? Because they weren't building it for us.
Oh, that's true. So in this example, I'd say that the orientation to the peak or the alignment with the peak was more important than aligning it with equinox, or what we know as equinox.
Right.
Right. Or those days may be important anticipatory observation dates. These
Or
are
they
all
could
things
become, or they could
Right.
become anticipatory
right.
after practice. So.
Or is it more about the journey over the mountains and it's close enough to be culturally significant to them at the time?
Indeed.
You'd have to have sort of some ethnography just to sort of see if this, of course, like festival dates or anything.
And I didn't think,
translate.
yeah. And the purpose of this question is not to answer.
Nope.
To answer it during this work session, but to start thinking about things like that. Let me speed it up a little bit. Wallace Pueblo is another one that was looked at. There's some things here you can read on your own. Everybody has this. So here is the best available Google Earth Pro image at the Wallace site. So the announcement that went out today also included a download for a Wallace 50 feet KMZ file that if you download and then you right click on it, it will actually, you have the option to open in Google Earth. So when you do that, if I click on it here now, this will take me to the site of Wallace Pueblo, and it will take me to reset it.
It's really beautiful. Hey, Chris, do me a favor. Can you just click it on and off? Just go and uncheck it and check
Yeah,
it.
that's
See
that's
what the
that's what
difference is?
I'm looking for
Okay.
the
You're trying to get
looking
it.
for the transparency slider.
And just for everybody's information, the KMZ file was generated from the drone flights that we did at Wallace in this last May.
Right, I could do it this way. So here's without it.
Yeah. Yeah.
And there's with it.
That's a big
So-
difference. And you can see Ray Williamson's truck there too. So that's really cool.
So the point of this exercise, and it walks you through it, is really just to yeah, you know what? So if I click on Wallace here, I should have, oh, there it is. That's what I'm looking for. So if you click on Wallace, let's go back to our view and our reset tilt compass. I'm extremely glad I learned about that tonight. And then you can click on this icon right here. This is our transparency. So you can bring it in and out as much as you want to blend the two images and to see how well it fits. And once we have this image, which was produced by the team, we are in a much better position to actually measure angles.
Hey, Chris,
Yep.
I couldn't hear very well. How did that superimposed image get made? What is that, from a aerial photo or a drone photo?
These are okay, Chris, if you want to. No, I don't know, your voice is pretty
I'll
bad.
let Chris answer that.
Right. So we flew a drone over the site. It's not gonna be good. We flew a drone.
I can take it. So
Yeah.
part of our process, Chris has this really super cool drone. And so we did several almost hours of drone imagery, and Chris will have to correct me, but this we did it from a lower level, like 50 feet above the site, back and forth and all this stuff, and then up to 200 feet above the site. And we tried to also get out into the sort of hinterlands a little bit. So this was all done, I guess, whatever this was, 4 or 5 weeks ago, when the team went out there and sort of did all this.
Yeah.
But this actually turned out really, really great. And so
Yeah,
I
really,
love how
really,
this
really,
slips into.
very nice.
And,
So do you then
it's also, I have to, let me add one more thing.
do you geo-reference it, or do you just like fit it as best you can, or is that geo-referenced?
No,
It was-
the photos, when you're the drone is referenced. So when it's taking the photographs, all the photographs are referenced. Then we assemble the photogrammetric model using Agasoft by Metashape, and then from that file we generate the KMZ file. Like
Nice.
this.
Yeah, sweet.
And we do have ground control planes.
Yeah,
I
we
have
have
it corrected for you.
Yeah.
So
And you
I
can
don't
see
know
how
if
really nicely it does.
I think that's really amazing. That's really super cool. What a big difference it makes.
Exactly. And the point of this exercise then is, before this was really unmeasurable with the images we have. If we skirt through some of these different images.
I found one historic image that was a little better than all the others, but it's nowhere near what we put together.
Right.
So
Right.
it's interesting.
So the next slide, I mean, this demonstrates here, the download process. you can navigate right to it. Once you open the file in Google Earth, we have the slider transparency. Of course, again, you can pick up your latitude. But now, and we won't go through this tonight just for the sake of time, but on your own, there's another set of questions that go with this Pueblo. Now that you can actually see the lines, the question is, which axis do you want to measure? So if we scroll back up, we have different options. We have almost like this north-south axis we could measure, but would that really provide any kind of thing useful to us? Or do we want to measure this direction, more east-west, west direction? And what are the kind of decisions we want to include when we determine which axis we want to measure?
So we had the advantage. Let me just explain this particular thing. So first of all, Bruce, who is running this site, actually had a total station sort of mapping of this whole thing several years ago. So he created a fairly accurate map after that survey technology. When we went out to ground truth stuff, I chose the wall, the one that goes northeast to southwest, because it's the straightest wall. Also, Bruce was there with us, and he knows what has been rebuilt and how it was rebuilt. And so he was able to verify the accuracy of certain of these features based on his work out there for the last couple of years. And so we picked that one, and I used it not only for essentially that particular angle and how it aligns to an azimuth, but also the size itself. So we measured corner to corner. So now I have a field verified azimuth angle and a distance measured in the field. And so that's what I use then to do further calculations later.
Right. Now, what I would have personally chosen, I would have probably chosen this wall. Now, it doesn't seem as straight, but I would have chosen this wall with a bias based towards like the research of Kim Melville and Andy Monroe, further south in Chaco. This is
here's
the angle that they would have measured.
So actually, there's another benefit of our knowledge. The one that I was talking about is specifically an exterior wall. Right. The one you're talking about actually has more building to the northwest of it. See where all those trees are? All of that is part of the Pueblo. So you're looking, that wall is an interior structure or interior to the unit. So if you trace that one all the way across, you'll see a little tiny red dot past the other corner. I don't know how to describe how to get to it. Just go straight across that wall and keep going all the way across the bushes, all the way to the other corner of the building, all the way.
Further,
keep going. Further. Keep going. All the way about right there. Yeah. So zoom in on that, and you'll see actually if you can zoom in, there's actually a little red marker there, or an orange marker. I don't know if you guys can see it.
Mm-hmm.
So I established that with the archaeologist. So I established that marker with the archaeologist as his understanding of the corner of the Pueblo as it exists.
Okay.
You see where we're talking about?
Sure. You're talking about basically.
Yep. Yeah. So that actually is that would be what the original exterior of the building would be. But the only reason I knew that is because Bruce was there and we walked through the project before we started, and he was able to say, okay, here's what's real, here's what's not real, here's phases, here's where I think an alignment was, here's where I know an alignment was. So I had the benefit of having all of his information before we started. So.
Excellent. So I'm just going to move ahead for the sake of time. Those questions are there. I think if we want to maybe run through them on our own. So basically, this is what we were just talking about. Which axis would you measure? The latitudes, clearly we can pick it up. There's azimuths, you know, in both directions, depending on which we want to go, you know, the more north-south or the east-west. The basis behind this question is there a horizon feature corresponding to that orientation? The thinking here is you could pop in your coordinates to, hey, what's that? And just, you know, look around and see, is there a peak? Is there anything interesting on the horizon? And does it align to one of my azimuths? And of course, you could figure out the rest of this through your measurements and your calculations. Just one of the other tools that I wanted to throw in here. This Pueblo is part of the same heritage center that Escalante is. So it's right there at the same spot. The whole basis of this is to download this image, which is just a line drawing. And what we can do is let's go back to Escalante. And if we come down here to the Heritage Center, this Pueblo is actually right here in this thing, in this little garden area outside the visitor center. So you can kind of see the walls there, right? This is our best image. But what we could do, if we wanted to, we have the overlay tool here, where we could browse to the image that is also in the invitation. Right here, we can open this guy up, and he pops up like this. So our control points, where did they go? That's not what I wanted to do. Let me get rid of him. I'll move him over here. So what we want to do is first we can resize it. This guy, I'm going to have to get rid of him. So let me try that again. I'm going to pick the image. I'm going to change my my transparency, and then I'm just going to play with these green control bars until I can align this line drawing with what I see on the ground. And again, I'm just gonna rush this for the sake of time.
About right.
You happen to know if you can lock the aspect ratio so you're not
Yeah.
messing with it when you're sizing?
Using the shift key.
Oh, okay.
Yeah.
That's really handy. I like that.
So let me zoom in a little bit here. Doesn't look like we can get to the get to the tilt yet, but you get to the point. I mean, you can get this until you're happy with it, and this is really just pretty much more of the same. Instead of having a great model that we can use to drop in here, you know, if we have a sketch, a site sketch or something like that that we can drop in, then it might help us, you know.
That's a handy tool. I didn't know you could do that.
Yeah, so now we might be able to come up with an azimuth or a heading with a little bit more confidence. So the whole purpose of this exercise is to take that line drawing, drop it in, line it up, and come up with a line of the long axis, the major axis, and just record what that is. And the last exercise, probably won't have time to go through. What is Lowry? Lowry is a site that the team has not yet surveyed. So this was to be the first step, you know, to get a leg up on the actual survey team, right? So none of this is really supposed to take the place of field work. It's supposed to be a good tool to go in, you know, proceeding your field work. That's exactly what this workshop is for. The boots on the ground for the cultural landscape survey project hasn't been here yet, so this was an opportunity for us to go through some of this stuff. Again, my question is, what axis would you measure here? And again, I think Rick would measure this axis. I would be inclined to measure this.
I think the longest, straightest outside wall is what I would do.
Right.
So
again, what I would probably suggest is you know, it's just a bias, I guess, on my part. It would be go back again to Monroe's doctoral thesis and some of that stuff, and read some of the reasons why they chose certain axes to measure, and of course
the other, I guess I would add to that is I would assume by now Lowry has very accurate measurements of every. I mean, there should be like almost a CAD accuracy plot of this the site by this time. I've only ever that somebody did that. So if you if you really had to know, then you can measure all of them or any of them. So.
Right. But of course, that brings us back to, you know, cultural significance. You know, what might be found, what might be said. Again, this is kind of another worksheet to go through for the Lowry site. We're not going to have time to get to it tonight, but everybody has the tools now to go through. I'd be interested to learn, you know, or to find out if anybody wanted to continue this afterwards on their own, and maybe yeah, the result, you know, we could share our results with each other. And then my last slide here is, these are potential sites that we could add to cultural landscape survey project through Google Earth, sites that are on private land that we don't have access to, that are culturally related or at least geographically related to some of the sites we looked at, if we wanted to expand. And really that's it.
Is Chris, do you think, would you mind if I just take a moment to show you just a couple of really
Not at all.
Horizon tricks?
Yep, and I'm going to stop sharing and hand it over to you.
So this won't take long. I'm just going to get, let's see. So this is sort of the start page for Horizon Systems, and you already saw Chris went through this. You can choose any body, you can choose any location, you can choose any time specification. I did another one here, minutes. Remember what Chris was doing is he was doing days for a year. I did one this afternoon for minutes for 3 days, and it just, you know, it's 3,000 or 4,000 lines, but you can do it. But then in this table settings, let me go back to that. And we were looking at this area over here. So you have astronomic, right ascension, and declination. And then when you get down here, you get apparent azimuth and altitude, or azimuth and elevation. And then notice these little check marks right here. See that little symbol, and this one down here on 31? That relates to this sort of thing, affected by optional atmospheric refraction setting. So there is an optional setting you have here. Let me go down to that. So see this, it's about the fourth line down, says refraction model. And you only have two choices. You either want the model or you want what they call no refraction, airless, and you'll check that. I typically just leave the refraction always on, because usually we're talking about horizon events. Refraction is going to be more important at a horizon than in the rest of the sky. And so I tend to just leave it on. But then back up at the top of settings, how do I get there? See this, so there's actually not only atmospheric right ascension and declination, but there's apparent right ascension and declination. And so if you're doing the calculation for like when solstice is, when the sun is in its position in space, so the relationships in space, you're going to want the atmospheric astrometric one. If you're doing our kind of work and you want to know when something is going to hit the horizon, you probably want to use the apparent one. I would check that one instead of that one. And so there's, I think you understand the difference. Basically, one is how things are happening without the atmosphere. The other one is from our particular point of view. And so that's it. One more, so that's one thing. You can try it both ways. I did it today. I just basically did both of them, and I could tell there was about 40% of a degree off in the two calculations. So it makes a big difference. It makes a difference in the thing. The other thing I just wanted to show out is see this little check mark right here, use CSV format. This is actually kind of handy because you can actually, once you've generated, so I leave it on, use CSV, I leave it on, and then I'm going to use specified settings. When I run this ephemeris, I get a thing right here that says download results. And then that delivers to me a text file. And now this is the text file we just churned out, right? So these are all, what's this? This is every minute for today. Oh, because it's solstice, and I was looking to see when, when the solstice was going to happen. Now, this is kind of cool. Is you can take, you can go into Excel. Everybody knows how to use Excel, I'm assuming. I'm going to start a new document. I just happen to know that I want to make these things a little bit wider than they are.
No, we can't see the Excel, Rick.
Oh, yeah, I'm sorry about that. Yep.
You have to share your whole screen.
Let me stop and then share. Okay, so now I'm in Excel, and I'm going to use this thing. And if I go to File and Import, I'm going to import a CSV file and import, and then I'm going to have to find it in my downloads. And I know just by doing it today, it starts with an H. It's way down here. Clean out your downloads more often than I do. And so it's going to be this Horizon results get data. I'm going to see delineated. You'll have to play with this. I'm not going to spend too much time. I'm going to check this comma separated because I happen to know that's important. Import. And now I essentially have the same data in an Excel file. I can get rid of columns that I don't want. And so now I basically have the columns I do want. And then you can use this and sort this. So if you're looking for a particular declination or something like that, you can basically sort by the elevation number, the elevation column over here, and it'll just kind of give it to you in order. It happens to be in order now because of course the elevation changes every minute, but this is a really tremendous program, and this makes it just completely sortable and searchable. You can take big, huge chunks of data for years and kind of scale it down to another thing, pick a section, then do something with that, and then pick another section, then do something with that. It's really a remarkable kind of fun thing to use. And so I just want to sort of, I encourage anybody, we used it a little bit in this thing, but go into JPL Horizon, just play with it, and just sort of just see what it turns out. See if you can figure out checkbox things and undo them and use refraction, but don't use refraction. Just find out what it does. It's really kind of cool. All right. Anything else, Chris, to finish off the program?
I don't have anything else. I hope you guys enjoyed it. There's a lot of things that you can finish off on your own. I probably will work through it myself. Like I said, I didn't work through any of it beforehand because I wanted us to all discover at the same time. So I'll probably poke around with some of the exercises at Lowry and Wallace afterwards. Next month, I will just be getting back from my field work in Belize a couple days before Journal Club. So I have an idea for a paper. Chris, if you know, maybe somebody wants to put it together, I can talk to you about that. But thanks for
I think I see Chris shaking. Chris is shaking his head.
Yes. Send it to me.
And
All right. Hey,
Chris, if you could, the little Excel spreadsheet that you use for calculating the declination, could you
Yes.
email that to me? Because there's been a request to have it posted on our website.
Let me first check with Fabio if that's okay.
Oh, okay.
And at that point I will do it. I tried to embed it into the presentation, but it didn't work out so well. But
Okay.
but until I get back with that, as Bill pointed out, let me get to his web page. You know what? I'm not sharing. Let me share real quick.
Right. I've read the speculation calculator down the bottom there.
And
It's under tools.
Declination calculator. There.
yeah, there it is. That's good.
Yep. So it's basically the same thing.
Yeah.
So yeah, I'll drop that in the chat if anybody wants to copy it. But it's certainly a quick search.
I hope everybody agrees with me that this idea of this little mini workshops, in fact, this one might have been too long, but I mean, we could sort of scale it back and kind of get a sense of, but I mean, delivering like a little, hour session, many times a year, I think that would be really super cool.
I think this is a good format to use, especially for the summers for us when people are out and about and traveling around more.
Okay.
Kind of a workshop-y, more applied. Cultural astronomy during the summers, and then more reading and paper formats in the winters. Might work good.
I think it worked great. I think this is really good. So, and maybe in the near future, maybe next month or the next after that, we'll be able to show more results of what we actually came up with at Escalante as the first one. We're trying to just get some sort of finished document. So we can kind of walk through, I think, all the pages and why we chose what we did and all of that kind of stuff. I think that would be a good workshop to show people.
Yeah, and if we either want to pick Wallace or Lowry and work through those questions, maybe we could right, have put or paste our results maybe somewhere on the webpage or the Facebook group or some place where we continue the dialogue
Yep.
I think,
outside.
Greg, did you see Kent's thing there? I think. Is it him?
Pardon?
There was a chat from Kent, just sort of where do we send results? So I think that's exactly what we'll have to come up with. Do we have like a shared? Can people go on our website and send us stuff? How does that work?
The email addresses we have, that's about all we have. We don't have a place to put things on the website per se,
Like a forum.
chat or anything like that. So yeah,
Yeah, like
inquiry at SCAAS.org is our general website address or email address.
And somebody's probably non-manning it.
Yeah, well, we could take that conversation offline. I think that would be interesting, at least to have a place, a forum, whether public or private, that we could.
We've done that. We really
At
want
the university, everybody's using a new thing, and I can't remember the name of it, like Slate or something.
Slack.
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 Yeah, maybe Slack is what it is. Yeah. Yeah. So anyway, people are really liking it. I haven't used it yet, but maybe that's the way to do it. Is just sort of get something that everybody can just feel free to get onto and share ideas.
Yeah.
So
No, that's
I like
about what
that
this
idea.
is all about, is going through and trying to figure out what we need, how to interact with each other on these things, how to share data, how to visualize data, all those kinds of things. It's all part of the Cultural Landscape Survey program. So
Yeah, the Slack idea sounds very good. That might be a great thing to cut the social media team loose on. I think that's freeware, right? That's open source.
I'm not sure.
It's
I get it. We have
it's
teams using
equivalent
it
to
at
like-
the university, but that doesn't make it free.
Yeah.
So,
right. It's equivalent to Microsoft Teams.
Okay.
Which is, my round the clock way.
all right,
Very
all right,
good.
everybody.
all right,
Well,
very
thank you,
good.
Chris.
Great job. Great
everyone.
job. Thank you,
Yeah,
Chris,
great
for
job.
putting this
Thank
together.
you
It's
guys for
excellent.
for the great input. I learned a lot too from you guys tonight. From Bill and Rick. That's so I came out of this learning these tools a lot better myself. So
Yeah.
Me too.
I did too. I learned a lot of things about Google Maps that I didn't know. So
I use it every day and I learn something.
Yeah.
So.
good.
Yeah.
Okay, there you go. All right. Thank you, guys.
Well,
Hi,
All
guys.
right. Good to see everybody.
Good night.
thanks much.
Good night.
Y'all later.